Hello everybody. In this video we're going to study about binary multiplier. So I have taken a general structure over here and try to explain how the multiplier is working through this equation. So you can see I have taken 2 bit, that is b0 and b1, and I have taken a0 a1, right? So when multiplying this a0 with b0, I'm getting a0 b0 over here. Then I'm getting a0 b1 over here. Just like our general multiplication. Then I'm finding a1 b0 just below this term, and then finally a1 b1 over here. Okay, now you know that when in multiply we have to go for partial addition. So what I've done first, after first multiplication, the second term I have shifted one position to the left hand side, right? So here whatever output we will get is nothing but the a0 b0 is coming as c0. C is just for representation over here, so c0 I'm getting over here. Then I'm adding a0 b1 with a1 b0 and I'm getting a factor c1. Okay, then I'm getting a1 b1 as c2. Now what is c3? C3 is the carry. For example, if I add these two, I may get a carry. I may get, okay, it may happen that you may not get a carry, but chances are that you may get a carry. So when you get a carry, that will come over here, and when you add the carry with this a1 b1 term, you may further get a carry. Okay, if you're not getting, then c3 terms will not be available. If you get, it will be stored in c3 term, right? Now if you observe this, what you're finding is here I'm getting 2-bit addition. Here there is no addition, so directly after ending, whatever term is coming, it's coming over here. But here this is a bit, this is a bit, so 2-bit addition I'm getting over here. Okay, and if at all a carry is generated again over here, I'm getting a 2-bit addition. So we know by this time that if 2 bits are there, we can use half adder. Okay, why I'm using half adder, what is 2-bit addition? If you want to know, then you can refer my previous videos, right? So accordingly I have designed a circuit over here. You can see I have taken a0 a1 over here, and because I'm multiplying a0 with b0, that is nothing but I'm just ANDing it. So I have taken AND gates for that, right? So you can see I have taken AND gate, and to that I have given b0 and a0. Okay, so when it is ANDed a0 and b0, I'm getting c0 over here. So in the equation also I represent the same thing over here, c0. So a0 b0 is coming as c0. Okay, and now the next AND gate is giving me a0 and b1. One leg is getting b1, one leg is getting a0. So a0 b1 I'm getting, and it is fed to half adder, right? Similarly a1 and b0 is coming through an AND gate and fed to half adder. So this half adder will give me sum, that is nothing but c1, and if a carry is generated, it will generate a carry. The carry is passing over to the next half adder where I'm having a1 b1. You can see from the left hand side a1 b1. So this a1 b1 I'm getting into half adder. Okay, getting it means I'm just feeding it to half adder over here, and the carry generated, if at all a carry is generated, it is coming to this side. Okay, so I'm getting 2 bits over in half adder, so which is giving me result as c2, and if at all carry is generated, it will come as c3. Okay, so to better understand the circuit, I have taken example over here where in place of b I have taken 1 1, that is b0 and b1. In place of a0 a1 I have taken 1 and 0. So in general sense, if we multiply this, what are we doing? 1 cross 1 is 1, 1 cross 1 is 1, right? Then I'm shifting one bit position towards the left, so I'm getting 0 into 1 is 0, 0 into 1 is 0. Then I'm adding it, so I'm getting 1, this will be 1, and this will be 0. Okay, so here c3 is not available because c3 is 0 over here, right? Because there is no carry generated. So I'm going to put this value on this circuit and trying to verify that my circuit is properly working or not. Okay, so you can see over here what I'm going to do. In place of b0 and b1, I'm going to put 1 and 1. So here b0 I have taken 1, b1 I'm taking as 1, here b0 is 1 and b1 is 1, right? And then for a1 I'm taking as 0 and a0 as 1. So a0 I'm taking as 1 and a1 I'm taking as 0. Okay, now let us see. So from here a0 will be coming as 1 over here, so 1.1 is 1, so c0 will be 1 I'm getting. Coming to this side, this is again 1, a0 is 1 from this leg. Okay, so 1.1 is 1, so I'm getting 1 over here. This a1 is 0. Okay, so 1.0 is 0, I'm getting 0 over here, and over here 1.0 again, so I'm getting 0 over here. Now in half adder, if I fed 1 and 0, okay, so obviously sum will be 1 and carry will be 0. So this 0 is carrying forward to this side. Okay, now 0 0 fed to half adder, I'll be getting sum as 0 as well carry as 0. So you can see the answer is 0 1 1. I'm getting the answer 0 1 1. So this verifies the circuit is working properly, and this is for 2-bit multiplier. Now the same concept if I apply for 4-bit multiplication, okay, that means I have taken 4 okay, so there is a corrections over here, so let me rectify this. So this is not exactly 4 cross 4, it will be 4 cross 3, it will be 4 cross 3. Okay, now so what I have done is that I have taken 4 bit in B and 3 bit in A, that is B0, B1, B2, B3 is 4 bit, and A0, A1, A2 is 3 bit. Okay, sorry, this is 3 bit. Okay, now the same thing I have done, I have multiplied A0 with B0 and B1, B2 and B3, and then if each after each multiplication of A0, okay, when I come to A1, I'm shifting 1 bit position. Again for A2 also shifted 1 bit position. So you can see over here what exactly the things are. For A0, B0 it's C0, this is 1 bit 2 bit addition, sorry, okay, but here it is 3 bit. So since this 3 bit addition, I will prefer over here full adder. Okay, so accordingly I have taken full adder circuit over here, you can see, and C6 is nothing, just like over here C3, C6 over here is the carry if at all regenerated. Okay, so what I've done is that A0 and B0 is coming directly as C0, okay, and then comes to this B1, B2, B3, okay, of A0, okay, that is B1, B2, B3, you can see over here, okay, that I've taken through AND gate. Now to full adder, what I'm giving 4 bit of A and 4 bit of B I should give, okay, as per the 4 bit parallel ladder which we have seen. So that means I should have 8 pins, input pins. So you can see over here this 3 term, because A0, B0 have taken directly out. Okay, so starting from B1, B2, B3, I'm having 3 bits. So what are the 4th bit? 4th bit I will take directly 0. You can see over here 4th bit I will take directly 0. Okay, then I'm adding with what? The second, because this is a partial addition, so A0 term will be added with A1 term. So A1 term having 4, that is B0, B1, B2, B3. You can see the equation over here. So these 4 terms are added with these 3 terms. So 8 pins are there. So 4 pins of A0 will be taken as B1, B2, B3. The 4th one will be taken as 0. Then all the 4 pins of B0, B1, B2, B3 will be given by A1 and subjected to the 4 bit parallel ladder. Okay, so it will give me a sum as well as carry. Okay, so that means 5 output pins are there. So first pin is giving me C1, so this A0 B1 and A1 B0 is added out, okay, and that will be giving me C1. I'm taking out the C1. Next 4 pins I'm subjecting to the next parallel ladder, because again A2 term is pending. So A2 term will take 1 2 3 4, right? So 4 bit or 4 pin it will take. So I've taken 4 pin over here, and from upper side, upside, you can see this 2 will give me result of 4. There is 1 2 3 4, right, and carry 1 5. So 1 2 3 4 5. So 1 I have taken out from here, C1. Rest 4 pin I'm subjecting to 4 bit parallel ladder, right, and 4 pin of A2. This is giving me 8 pin input. Okay, so which I'm getting over here, and final output I'm getting as C5, C4, C3, C2. Okay, and 1 carry. So altogether if I see, I got C0, C1, C2, C3, C4, C5 and C6. You can see the equation I got in the same way. Okay, so this is how we are using the concept to get multiplication done through this circuit. Okay, thank you for watching my video.